Right, let's have a look at this question. So Anne is having a new front gate made and has decided on the design below. The gate is 2 meters wide, so that means that's 2 meters, and 1.5 meters high, so that's that, straight obviously, and then 0.5 meters apart. Sorry, what did I, oh, the horizontal bars. So that means this is 0.5, this is 0.5, and that one is 0.5. Okay, calculate the common length of the bars AF and DE in meters correct to 3 decimal places. Right. So DE. Okay, so this is what we're looking for here. So if I just make a triangle, so like that, then we can do Pythagoras. I'm going to call the yellow line X. So we have x squared equals 2 squared plus 1 squared. So x squared equals 4 plus 1. X squared equals 5. And then square root both sides. So it says 3 decimal places. 2.236 meters. Okay, in order to secure the bar AF, okay, that's that, to DE, okay, so it's crossbars, right, Grant? The manufacturer needs to know the measure of angle EGF. So the measure of angle EGF, I'm going to let angle EGF equal E. I'm just going to, no, I'm not, sorry, EGF would be G, not E. So I'm just going to mark it in here. Yeah? And then the common distance AG equal to DG. Right, so it's like the same line we just got, but sorry, like just a part of it, that bit of it, that's DG, and then AG is the same length, but it goes up and down here. Okay, find these measures, give the angle correct to the nearest degree, and the length correct to 3 decimal places. Right. Can we... So we know the length, well, we know the length of that bit. Does that help? And then we have a little triangle. The measure of angle EGF. So if we use the triangle that we've just used, so the one that's yellow, green, green, that one, and we use it to try and figure out this angle. So, sorry, it's messy. If I call this E, yeah? So, but I'm going to work in the big triangle. So that would make this side here the opposite. Yeah? That's right, isn't it? It is. opposite the right angle over here, the x would be the hypotenuse, the whole thing from the first part. And then this one over here between E and C would be the adjacent. So if I use these two, the opposite and the adjacent, it's a right angle triangle, so I can use SOHCAHTOA. So that would be TOA. I think that should work to give me that angle. So if I use TOA, then I've got the tan of the angle is opposite over adjacent. So the tan of the angle is, the opposite is 2 and the adjacent is 1. The opposite is 2 and the adjacent is 1. So then to get the angle, I'm going to do tan inverse of 2. So inverse tan of 2. So I'm getting 63.4349. Okay, so if I can zoom in a little on this, sorry. 63.4349. So that's what that is. 63.4349. Yeah? It says that, so we know that A to F is the same as D to E. It said that there somewhere. The common length AF and DE. So AF and DE are both 2.236 meters long. And then it also says that AG equals DG. So like AG, so this bit of that line equals the scribbly bit of this line. So that means these two must be the same. GE must be the same as GF. Yeah? That means that's an isosceles triangle, which means this angle is also 63.4349. So then by subtraction, I think I can get, so multiply that by 2. So if I subtract from 180, I get 53 point, I'm just going to go back down here. So I'm going to double that because I figured it's isosceles. And then I'm going to do 180 minus that answer, and I'm getting 53.13 degrees. Sorry, I will put that number in now. So it's 126.8698976. I'm just holding the whole number. Sorry, move over. So that's 53.13, and I think it said to the nearest there. So to the nearest degree for the angle. So that is approximately equal to 53 degrees for angle EGF. Yeah? Okay. And then they want to know the common distance. So I suppose if we find the length of GE, we know the length of DE. So by subtraction, we can get DG. Does that make sense? Will I write that down? That's a lot of letters. So the length of D, the length of DE, which is the whole line, is equal to the length of DG plus the length of GE. Yeah, so the whole line is this bit of the line plus this bit of the line. We're looking for DG. This is the one we're looking for. We know that this is 2. don't know that. But if we can figure out what GE is, then we'll be able to get the missing one. Yeah? So, we know the angles. We don't know the sides. We do know this side, though. I think we can use the sine rule. Yeah, I think we can. So, you know the way you always start with the side opposite the angle for the sine rule? So we'll start with 0.5 squared. And this side that we're trying to figure out, we'll call it x. No, sorry, I called the original thing x. We won't call it x, we'll call it y. Yeah? And we know that, what did I say this was, 53 degrees? Okay, so the cosine rule, if I just do it here just so we can keep looking at it's a squared equals b squared plus c squared minus 2bc cos a. And a is always the side opposite the angle. So that's going to be our 0.5. And then, so this is going to be our 0.5 and this is going to be our 53 because they always have to be, they always have to be opposite each other. Yeah? So we go 0.5 squared equals x squared plus x squared minus 2 times x times the cos of 53. 0.5 squared is 0.25. There's invisible ones here, and they're from the same family, so that's 2x squared. Yeah, and then this is minus 2x squared with the cos of 53. So you have to be careful there. You can't minus. Now what I can't, you can't do 2x squared minus 2x squared because the second 2x squared is with the cos of 53. So what I'm going to do is I'm going to multiply sorry, there's a 1 there, so I can multiply the numbers. So I can multiply the minus 1 by the 2 by the cos of 53. So minus 1 multiplied by 2 multiplied by the cos of 53. So this is what I'm getting. So I've got 0.25 equals 2x squared minus 1.2036 goes on x squared. Yeah, so those three that I multiplied gave me this, and then I still had the x squared there. Yeah, so these two are now from the same family, these two here, because they're both from the x squared family. So I can do that subtraction. I can do 2 minus, and I'm just using the answer button in my calculator to keep it as many decimal places as possible. So 0.25, and I'm getting 0.79636699, and it goes on, x squared. And then if I want to isolate the x squared, I'm going to divide by this number. On both sides. So it'll cancel on that side. On the other side I get 0.25 divided by that long answer. And I'm getting 0.3139. And again, it keeps going. So I'm just holding it in my calculator. And then if we square root. So square root of that answer is, it said, am I doing that right now? It said, oh, I'm actually not finished. Sorry, sure I'm not. Okay, I'm after calling it y in the picture and calling it x here, but it doesn't matter. Like, the maths is fine. So I'm after figuring out that EG, so the length of EG is 0.56028, and it keeps going. There's more. That's EG. That's not what they wanted. They wanted AG. Excuse me. So I need to subtract it from the full length, which was this one here, 2.236. So, I know this is all over the place, but to get AG, did I do that wrong up here? I did. Sorry, I said that DE was 2 up here. DE is not 2. DE is 2.236. That's what I got here. And then I'm just after figuring out that EG is 0.56028. So 0.5602, and there's more numbers to that. So now I should be able to fill in the gaps with subtraction. So that's what I'm doing. So I'm going to do 2.236 minus that number up above, 56028, which I haven't deleted yet. And that gives me that AG is 2.236 minus my answer. And I'm getting, what does it say? The length correct to 3 decimal places, 1.676. And it's all meters. Yeah, meters. So there is that answer. Yeah. Okay, hope that helps.